How to calculate the formula of a compound from reacting mass data from the topic of 1.1 The nature of substances and chemical reactions. The empirical formula of a compound is the simplest integer ratio of the atoms of each element in the substance. Take for example fructose, which has a molecular formula of C6H12O6 and an empirical formula of CH2O. The molecular formula has been divided by 6 in order to get to the simplest ratio of atoms. It is calculated using chemical data obtained from a reaction like reacting mass, giving the name to the formula empirical. Here is an example question for the calculation. A sample of an oxide of nitrogen is found to contain 30.4% nitrogen. What is its empirical formula? Well, the first step in answering any calculation question is first to identify the important information in the question. So for this question, it's the reaction composition, mass composition. So nitrogen is 30.4%, and if you subtract that from 100%, you'll get the composition of oxygen, which is 60.6%. The next step is to divide the mass composition by the molecular mass for each element to obtain the molar quantity. If you start with nitrogen, you divide 30.4 by the molecular mass of nitrogen, which is 14 grams per mole, and you get 2.17. Then if you do oxygen, you do 60.6 divided by the molecular mass of oxygen, which is 16 grams per mole, and you get 3.79. The next step is to divide by the smallest molar quantity in order to get the molar ratio. So the smallest molar quantity out of the two is 2.17. So you divide 2.17 by 2.17 for nitrogen to get 1, and you divide 3.79 by 2.17 for oxygen, and you get 1.75, which is roughly equal to 2. So you can see the molar ratio for this substance is 1 to 2. You might have needed the last step in order to get the formula into integer form, but it's already in integer form, so it is not needed. And so the empirical formula of the substance is NO2. The first past paper question is question 4C from 2017. Calcium silicide is a compound containing calcium and silicon only. A sample of calcium silicide was found to contain 2.0 grams of calcium and 2.8 grams of silicon. Calculate the simplest formula for this compound. You must show your working, and it's worth 3 marks. So step 1, identify the information. In this case, it's the reacting mass. Calcium is 2.0 grams and silicon is 2.8 grams. Next is to divide the mass by the molecular mass for each to contain the molar quantity. So for calcium, 2.0 grams divided by 40.1 gram per mole, which is 0.00499, and for silicon it's 2.8 grams divided by 28.1 gram per mole, which is 0.0996. Then divide by the smallest molar quantity to get that molar ratio. The smallest molar quantity out of the two is 0.00499, which is calcium. So you divide 0.0499 by 0.0499 and get 1. And for silicon you divide 0.0996 by 0.0499 to get 1.997, which is pretty much equal, roughly equal to 2. So the molar ratio for this compound is nicely 1 to 2. and no multiplication needs to happen because it's already in integer form. The second past paper question is question 7b from 2018. Chlorine reacts with aluminium to produce aluminium chloride. A sample of aluminium chloride of mass 26.70 grams was found to contain 5.4 grams of aluminium. Calculate the simplest formula of this chloride of aluminium. You must show your working, and it gives you the molecular masses of aluminium and chloride there in the question to help you. So the first step again is to identify the important information, which is the reactant masses again. The reactant mass of aluminium is 5.4 grams, and you can calculate that of chlorine by subtracting the mass of aluminium from the total mass of aluminium chloride, which gives you 21.25 grams of chlorine. Divide by the mass by the molecular mass for each to obtain the molar quantity. So if you start with aluminium, it's 5.4 grams divided by 27 grams per mole, which gives you 0.202. And for chlorine, 21.25 grams divided by 35.5 grams per mole, and that gives you 0.599. The smallest molar quantity out of the two is aluminium, 0.202. So for the next step, you divide for aluminium 0.202 by 0.202 and you get 1. And for chlorine, you divide the 0.599 by 0.202 to get 2.97, which is almost equal to 3. So this gives you the molar ratio of 1:3 aluminium to silicon. Sorry, chlorine. And you don't need to multiply it because it's already in its simplest integer form, AlCl3. And that is how you calculate empirical formula. Thank you for listening.